Alright, so let's start our next unit on quadratics here. Now the main goal behind this unit, last unit we looked a lot at standard form and factored form of quadratics, and specifically we also looked at how to go from factored form into standard form using expanding and simplifying. We did a lot of that work using arrays. And we want to be able to move between these two forms because each form tells us different things about the quadratic. So we know factored form can tell us the x-intercepts, standard form can tell us the direction of opening and the y-intercept. So while we did learn how to go from factored form to standard form, we didn't really look at how to go the other way from standard form to factored forms. That's what this unit's really going to be about. But first we got to look at this whole idea of greatest common factor. Now you saw this concept back in middle school. So if you're looking for a greatest common factor between 6 and 18, you're looking for the largest number that goes into both 6 and 18 evenly. Now you may be able to take a quick look at that and right away say, oh, the largest number that goes into 6 and 18 is 6. But the way you would have done this back in elementary schools is to take 6 and 18 and do what we call factor trees. So you could break 6 down into prime numbers, 3 and 2. You could break 18 down into 9 and 2. And of course 9 would break down further into 3 and 3. So to find your greatest common factor, you'd see what all these guys have in common. Well, they both have a 3, and they both have a 2. So the greatest common factor is 3 times 2, which is 6. And again, you may not need to go through this process for every single example. This is what you would have done back in the day. So try this again for 30 and 75. And if you try, the largest number that goes into 30 and 75 will be 15. If you look at 6 and negative 8, the answer would be 2, but also as a possibility you could take out negative 2 as well. Both of these would be acceptable greatest common factors, because again, both 2 and negative 2 will go evenly into 6 or negative 8. Okay, between x and x squared, if we were to try and take a factor tree approach to this, we'd have x and x squared. Well, x is just x, can't break down any further. But x squared we know breaks down into x and x. So in terms of our greatest common factor, they both have an x and that's it. So your GCF here is x. Looking between 15x squared and 12x cubed, you can take the same approach if you like. Deal with the coefficients first, at least I would. So between 15 and 12, the GCF would be 3. And between x squared and x cubed, okay, if you think that x squared has 2 x's that multiply to make it up, and x cubed actually has 3 x's, well then in common is going to be 2 x's or x squared. So you wind up with a GCF of 3x squared. Okay, and you can keep going. You can try the rest of these here. You can try this one. It has 36x squared, 48x, and 60. Now we have 3 terms. So what's common between all 3 of them? Well, you can't take out an x because the 60 here doesn't have an x, but you can take out what's common between 36, 40, and 60, which is going to be 12. Okay, and for this last one down here, again, bit of an extension here might look a little bit tricky, but if you deal with the coefficients and the variables separately, it's actually not too bad. So between 5 and negative 10, we can have 5 or negative 5 as a common factor. Between x squared and x squared, they both have x squared in common. And between y and y cubed, they both have a y. So you get 5x squared y or negative 5x squared y as a common factor. Okay, so why are we doing all this? Well, now I want to try and factor things, factor some expressions. And what we're basically looking to do here, I mean, if you picture back in grade 9, when you're given the example 3x times x minus 6, and you're asked to expand and simplify that using distributive property. Well, you would have done some multiplication here. You've gone 3x times x to give yourself 3x squared, and 3x times minus 6 to give you minus 18x. Okay, and you would have done that without too much trouble back in grade 9. What we're trying to do now is actually go backwards. Take something that's already expanded and try and figure out what the original factored expression is. So you might be able to recognize this original form here as a factored form, and this new one here as standard form. Well, again, we're just trying to go backwards here. Something that's already expanded is something that's already factored. So what we're going to look at here is actually trying to find the GCF. So between 3x and 9, the greatest common factor is 3. So we take that and we got to figure, okay, what would have been left over in my bracket if I factor out the 3? Well, one way you can look at it is, okay, I had 3. If I were to multiply this out, I have 3 times something to get 3x. Well, 3 times what gives me 3x? Just x. Okay, and then I'm going to have 3 times something to give me positive 9. Well, that would have to be plus 3. Okay, so I get 3 times bracket x plus 3. Now, the nice thing about these is you can always check your answers by actually going through the multiplication afterwards and double checking that it works out. So you can check 3 times x is 3x, 3 times positive 3 is plus 9, so you get 3x plus 9. Okay, let's try and take this approach to all the other ones here. So try and look for your greatest common factor for all of these examples here. And then again, you're going to see what's left over in the bracket. I'll do one more with you guys. So between 5y and 5, we have a greatest common factor of 5. Okay, what's left over? Well, 5 times y gives me 5y, and 5 times minus 1 gives me minus 5. Okay, so I'll give you, take a minute here and try all the rest, and push play and you're ready to see the answers. Okay, so there you have it. So take number 3, common factor of 2. Tiny little mistake here, this should actually be 4y here left over, because we need to get 8y. Here for number 4, this is the first time where you actually have a variable in common you can take out. So you can't just take out the 5, because that's not the greatest common factor. You can also take out the fact that we have an x squared and an x. We can take out an x. So we can take out 5x as our greatest common factor. Then we can figure out what's left over. Okay, 5x times x gives me x squared, so we get x here. And 5x times 5 gives me 25x. Okay, so keep going here. Here you take out 5a squared as a common factor. So if you're having trouble finding these common factors, I would deal with the coefficients first and then with the variables. So between 10 and 25, you have a common factor of 5. And between a cubed and a squared, well, remember a cubed has 3 a's, a squared has 2 a's, so you can take out 2 a's as a common factor. So you get 5a squared with 2a minus 5 left over. Okay, here if you look at the coefficients first, 3, 12, and 9, common factor is 3. And all of these have an a, so you can take out an a as well. Okay, next, so you can take a look at the next two here. 8 can be a little bit tricky, but again, look at coefficients first, then variables to see what's left over. And specifically now I want to talk about number 9. Number 9 looks a little bit different. And mainly what's confusing is having these brackets here. So let's just try and do this the old-fashioned way. Let's say we were back in elementary school trying to do factor trees for this. We'd have 4x times x plus 2. Okay, so that's my entire first term right here. And I'm adding 3 times x plus 2. Okay, so looking at in terms of common factoring here, so 4 breaks down to 2 times 2. X breaks down to just x. And x plus 2, again, it's a bracket so it looks weird, but there's nothing you can really multiply together to get x plus 2 because these are added together. So x plus 2 is just its own little factor here. Okay, so if you look at the other one over here, 3 times x plus 2, well, 3 is just 3. X plus 2 is just x plus 2. So what do these guys both have in common? It's actually going to be the x plus 2. This bracket of x plus 2 is actually our common factor. So this becomes what we take out. That's what gives the x plus 2 here. Then what's left over? Well, if I take the x plus 2 out of this part right here, I have 4x left over. If I take the x plus 2 out of here, I have 3 left over, so I have 4x plus 3 left over. So I wind up getting x plus 2 bracket 4 times 4x plus 3. And again, if this seems weird, you can always again check your answer. And remember that if you were to re-expand this out, you have to use distributive property. So looking at what we did last unit, we would have had to have taken x plus 2 and distributed it into the other bracket. So let me just do this as a check here. Clear all that out. Okay, so if I had x plus 2 times 4x plus 3. Okay, again, if I was to multiply this out, I have to distribute this x plus 2 into this bracket. So I have x plus 2 times 4x and x plus 2 times 3. Well, really, that's what I have when I started with my original question. So I actually have 4x times x plus 2. Okay, and then plus 3 times x plus 2. Okay, so it actually does work. Okay, just remember that here the bracket x plus 2 is our common factor. Alright, with that in mind, let's try a few others. So here I have 5x times x plus 4 minus 2x plus 1x plus 4. Again, what you're looking at here, if in terms of a common factor, they both have x plus 4. So that becomes my common factor. And what's left over? Well, I have 5x minus, and then this bracket here. So 5x minus the bracket 2x plus 1. So again, x plus 4 is a common factor. Here's what I have left over. All that's really left to do is to simplify inside this second bracket here. So I can distribute that negative through the second bracket. So I get 5x minus 2x minus 1, which simplifies it x plus 4, 3x minus 1. Okay, over here with 11, it looks like we kind of want to do the same thing that we did before. However, if you look very, very carefully, these brackets here, the x minus 5 and the 5 minus x, are actually not quite the same. Okay, in this one, the x is positive, the 5 is negative. In this one, the 5 is positive, the x is negative. So they're not quite the same. So I need to do a little bit of work with this one before I can actually try and factor it. So what I'm going to do first, I'm just going to rewrite the second bracket. So the x and the 5 are in the same order as the other one. I'm just going to rewrite this as negative x plus 5. Again, just so they're written in the same order. Now, if I were to take a look at this second bracket here, I could take out, if you look between x and negative x and 5, there's actually nothing in common. However, there's a negative here that in theory could be a common factor. So what I'm going to do is I'm going to factor out this negative 1 out of this second bracket. So just to show you what that looks like, I'm going to have 3x, x minus 5. Okay, I still have my minus 2. And what I'm doing here is I'm going to take out a negative 1 as a common factor between these. If I take out the common factor of negative 1, what's left over? So negative 1 times what gives me negative x? Well, that's just going to be x. Negative 1 times what gives me positive 5? Well, that's going to be minus 5. So by taking out this factor of negative 1 from this bracket, all of a sudden I have x minus 5 left over, and now this factor of x minus 5 matches this factor right here. So then I could try and do something similar to what I did in number 10. So again, just to make these brackets look the same, I factor out a negative 1. So I'm just going to simplify this a little bit here. So I get 3x, x minus 5. I have minus 2 times negative 1, which gives me positive 2. Okay, and now I can take out the x minus 5 as a common factor. And once I do that, I'll be left with 3x plus 2. Okay, so moving on, let's try 12. Now, at first glance, you're going to take a look at these 4 terms. You'll notice that there's actually nothing that's common between all 4 terms. Okay, so on the surface right now, not much we can do, but what we're going to try is something that we're going to call factoring by grouping. Okay, and it's something that we're going to try every time we see that we have 4 terms here, but no common factors. Okay, it doesn't always work, but it's definitely worth a shot. So what I'm actually going to do here, when it says factor by grouping, I mean literally I'm going to group 2 terms together, and then I'm going to group the other 2 terms together. So I'm going to look at AC plus AD as one group, and BC plus BD as another group. So what that's going to look like here, if I look at AC plus AD, well, what's common between these two? Well, they both have an A. And what's left over? If I factor out the A, I'm left with C plus D. Okay, so now I'm going to look at the second group. So I have BC plus BD, and what's common between these two, you'll notice that they both have a B. So I'm going to factor out a B, and I'm going to be left with, again, C plus D. Now, if this grouping is going to work, what I'm going to notice here is that these 2 brackets here, these 2 factors, are going to be identical. So now C plus D is a common factor, and A plus B is left over. Okay, now, again, grouping doesn't always work, but it's definitely worth a shot if we see 4 terms and nothing in common between all 4 of them. So we're going to continue this in the next part of the video. Please try 13 and 14 on your own, and we'll see you over there.